You are a manager of Dell, I'm a manager of Intel. I can tell you, look, I'm going to offer you CPUs at a discounted price if you grant me that you buy your CPUs exclusively from me and not from my rival. Is this good for competition? Is this bad for competition? The only instruction gave by the computer scientist was, you should maximize this profit and you should learn through the environment. And then the algorithm learns. If you manipulate recommendation too much, consumers may walk away, because you are recommending them products that are not anymore good fit. They realize that maybe they might buy once following your manipulated recommendation, but tomorrow they may leave the platform.
Hello everyone, welcome to Arth Niti. I'm Shekhar Tomar. Algorithms are everywhere, from booking hotels, from shopping, to finding jobs. Most of the interactions between humans are intermediated by some of these algorithms or platforms which we all know. Now, regulating these platforms has also become a very important question as we want to balance out the technological advancement with ethical concerns. However, how difficult or easy it is to balance these two objectives. To understand the nitty-gritties of these issues, we have Professor Giacomo Calzolari with us today. He is currently a professor of economics at European University Institute. Professor Calzolari has extensive work on industrial organization and competition policy. He has published in top economic journals, and some of his recent work has looked at collusion among algorithms. Welcome to Arth Niti.
Thank you.
So I'll ask a first question, which is also a super interesting question for me. So I did my PhD from Toulouse, just like you. So maybe you can tell us a little bit about your time at Toulouse. I guess it was in 2000 that you finished your PhD.
Yeah, that's correct. It was simply great. It was a great environment where to work on industrial organization. And it's still, by the way, of course. It was very much focused on I/O, contract theory, information economics, which were really the topics I was very much keen on developing my own research. And I met so many great professors and many great co-authors, colleagues there, because, doing a PhD is, of course, interacting with your teachers, your professors, your supervisors, but it's also working with peers. So sharing your tough PhD student life in that environment was simply great.
But did they have other fields as well at that point of time? Because when I was doing the PhD, they had almost everything under the sky.
Yeah, as I was said, by that time, I finished in 2000. It was more focused than it is today. But they were starting to expand their fields, and nowadays it's a fantastic department on many grounds. By that time, it was more, as I said, on the micro area, but now it's great on many dimensions.
So since you worked on industrial organization and your journey really started at Toulouse, I guess in some sense, it's also the school where all this discussion about competition policy started in Europe per se, because they had some of the best researchers at that point of time. So if I may ask you, you can tell us about what is industrial organization, what is competition policy in general, and if you can trace a little bit of history for us in terms of understanding why it started in Europe and what can we learn from it.
Sure. So industrial organization, or as we say in the jargon, is I/O. It's a field in economics that focuses mainly on behavior of firms, how firms act in markets, how they interact with each other, how they interact with consumers, and what are the implications of these market interactions in terms of market structure, profitability, efficiency, And of course, also on what is the impact on consumer surplus, which is one of the measures that we currently use, for example, that competition authorities use in order to assess the functioning of the market. So that's more or less the idea of IO. So I would say that Toulouse was by that time, and as I said, is still today a great place, because if I think about the development of the field of industrial organization, we may say that modern industrial organization started when that type of studies were somehow faced with these new developments in game theory. So we are going back to the 70s and the 80s, where these new tools, new concept of game theories that are, of course, designed to study strategic interaction between players in general, were started to be applied in particular for interactions between firms and consumers. That was the starting point of industrial organizations as a modern field. Then other developments were in the 80s and 90s, information economics and contract theory. That's why perhaps by that time Toulouse was a great place already, one of the best places in the world, because there were so many great scholars working on these topics. And then probably the most recent developments, starting from the 90s in industrial organization, were solid works on empirical industrial organization. Now we have I would say perhaps even a field per se, which is empirical industrial organization, that is based on solid techniques and new data, very rich data that were not available probably before the 90s.
I'm sure you must have looked at few cases or many cases related to finding out whether a particular market, sector, or firms are competitive enough or not. And I guess it's one of those fields in economics where you have a direct application per se. So which one is your favorite? Like, can you tell us like one specific model or case which you think explains this idea of competition, consumer surplus in detail?
Yeah, well, there are so many interesting cases that it's difficult to think about, but probably also related to some research I've done. There is a famous case that refers to the CPUs, that is the chip that we have in almost any electronic device, but also cars, cameras, phones, and etc., that are produced by a small group of firms. So it's known the Intel versus AMD case. It is actually not, so it's not a case per se, it's also an antitrust case. It's very interesting because it really speaks about one of the important elements of competition policy, which is contrasting the abuse of dominance, which is a tricky concept because per se we are not contrasting monopoly. If a firm on its own...
So if I may ask over there, like you've used like a bunch of terms over here, but what exactly is the case? It's Intel and AMD?
Okay, so Intel and AMD are the two largest producers of CPUs, which are really very important little objects that are filling our lives everywhere. Intel is a very large producer. By the 2000s, it had a very large market share, close to 80%, in some cases even more, for this market globally. AMD was, in some sense, a runner-up with a much smaller market share. And then there were other smaller producers. Right? So clearly, Intel had a dominant position. The question was whether it was abusing or not its dominant position, okay? And just to mention this little thing, these CPUs, and in particular the antitrust case I'm mentioning, was referring to the use, so selling these CPUs to computer manufacturer, okay? So I think it's an interesting case because it gives you the breadth of the strategic interaction we are talking about when we use our tools of industrial organization. It's not just production to funnel consumers, it's really also interaction between firms. So there was Intel that you can somehow figure upstream in the value chain of production that was selling most of the CPUs to computer manufacturers, to the buyers, consumers of
and
these
they are also
objects.
large.
They are also large firms. We are talking about Lenovo, HP, Dell. So these companies were the consumers, the buyers of this object. And then, of course, the next step in the value chain was final consumers, people like us buying computers and devices. Okay, so the idea was trying to understand whether Intel, having this large market share, was using this dominant position in order to abusing of this dominant position. So the tricky part there, the complicated part there, is that we are not against, and we should not be against large firms, because typically large firms are large because they are better, because they are more effective, more efficient, for example, in production. They sell better products, okay? What we have to distinguish is this scenario that in the jargon is called competition on the merit, okay, from abusing this position, okay? So the case was litigated worldwide in the US.
So when we say abuse, what are the variables we are looking at?
Yeah, we are looking at whether the possibility of being these large players allows this firm to exclude rivals in an unfair way that would have significant inefficiencies in the market. And again, we don't want to protect competitors. What we want to do with competition policy is to protect competition, which is a different thing. But you see that the boundaries can be blurred. So what I think is really interesting in using industrial organization for competition policy is this type of challenges. Concepts are not black and white, and you must find a reasonable line that separates and allows you to come up with some conclusion. This is good, this is not good in terms of practices. So, as I said, one of the practice was using fidelity contracts with these buyers, where, for example, I could tell you, you are a manager of Dell, I'm a manager of Intel, I can tell you, look, I'm gonna offer you CPUs at a discounted price if you grant me that you buy your CPUs exclusively from me and not from my rival. Is this good for competition? Is this bad for competition? It's a difficult question, and it's not by chance that it was litigated close to 20 years.
Because you can sign these contracts if it's in your favor.
As a buyer, you are not forced in principle to sign this contract. If I propose you this contract, you are free to say yes or no under some conditions. It's not obvious because if you don't sign this contract and you don't find an alternative source of CPU, you may go out of business quickly. No? You need CPUs to produce laptops. If you don't have it, we have seen recently in the car manufacturing industry that the lack of CPUs can have very important consequences in terms of lack of ability to produce cars. So it's not obvious that if you refuse my contract of this type, you can source CPU somewhere else. And that's where you really have to look for good solutions, good interpretation of this complicated case. So I've been working on exclusive dealing contracts. I have some papers with one of my co-authors, Vincenzo De Nicolois at the University of Bologna. And precisely one of the aims of that research was trying to give a framework that would allow you to tell you when this type of exclusive dealing contracts are pro-competitive, of course desirable by the firms that they propose, because otherwise they would never propose them, and whether they are on top of that also pro-competitive, or whether they are anti-competitive, okay? So this is the type of research I like to do. That is, it's a abstract research, because as I said, we are using these game theory, contract theory framework, which is some nitty-gritty math, if you want, but is used to give clear answers or help providing answers to competition authorities to address very important cases.
So in your case, the one you mentioned about exclusivity contract was between computer manufacturers and these chip makers, but I guess it's fairly general.
Yeah.
Even if you go in a supermarket, I guess almost all brands have to sign a exclusivity contract with Walmart or whoever the big player is in the region.
Well, I would say, yes, those are other environments where you can observe these type of contracts. Sometimes they're not as stark as exclusivity. There are other versions that are named market share contracts, where I give you the discount if you guarantee a minimum market share. So you are allowed to buy some from other sources. Yes, supermarkets are other environments where you would observe this fidelity. In general, they're called fidelity contracts.
But just to close the circle, so the case of this AMD versus Intel, like it was all across the world, I guess.
Almost all across the world, because you understand that it's such an important industry that affects everybody. So it was settled relatively quickly settled in the US.
Which year are we talking about?
We're talking about 2005 for the US. And it started, for example, in Europe 2009. And the interesting thing is that from 2009, we had the last decision in 22, last year. So it's called the Intel saga in Europe, because there were many different steps where the decisions were overturned, and it's a very complicated case, and that's why I think it's quite interesting.
So abuse of dominance is one part of this kind of antitrust policy or competition policy, but are there a few other cases that we can directly say, okay, these are clear-cut cases where you can make a case about competition policy?
Sure. So antitrust authorities, they broadly speaking, they work on three areas. One is contrasting abuse of dominance. The second one is contrasting collusion or cartel formation, general cartels. And then there is this merger review analysis, where antitrust authorities somehow give you green, yellow, or red line when you decide as a company to merge with another firm, okay? Because we know that market concentration, which is an implication of a merger, may have consequences, significant consequences on markets, sometimes non-desirable consequences, not always, but sometimes non-desirable consequences. And so, more or less, all over the world, antitrust authorities, they are involved in the process of allowing or not these proposals of mergers, and sometimes mergers and acquisitions.
And the underlying object in most of the cases is looking at what's the consumer surplus.
Yes, that's more or less commonly and generally the metrics that authorities use to assess whether particular behavior of firms is acceptable, green light, or non-acceptable, red light, in these different areas. And there is nowadays a debate about whether this criterion of consumer surplus is the only element that authorities should take into account. But that's a completely new area, in a sense, very important and very interesting.
But in general, like, I don't know if it would be too detailed, but how do you measure this consumer surplus? It still sounds esoteric. In terms of the toolkit,
sure.
I guess.
Yeah, no, I think it's in a sense relatively simple. So the idea of the consumer surplus is what is left to a buyer once the buyer has decided to buy a certain product. Okay, so the buyer will buy a certain product, will generate what economists would call utility or well-being, the fact that you now can consume this product, but you have to pay for that. Okay, so the net as value that is left after you pay is the consumer surplus. That's the idea. Now, there are techniques that allow you to measure this consumer surplus in a pretty precise way. And they're based on estimation of demand functions, which is a key concept in economics. So there are empirical techniques that allow you to identify a demand function in a specific market. Once you have done this, it's done with econometrics, which is a branch of statistics that allows us to do this type of analysis. Once you have a proper estimation of the demand function, then you can assess what is the consumer surplus associated with different price levels. And hence, any of the strategies of firms that affect the price level will come with a change in consumer surplus. That's the way you more or less address these issues.
So again, going a little bit on the tangent, but you said people want to include a few more dimensions to knowing whether it's a good behavior or a bad behavior by the firms.
Right.
So consumer surplus is one. What are the other elements that are being discussed?
Right. So nowadays we are discussing a lot about the impacts of production on the environment, very broadly speaking, right? So, there is a discussion going on whether antitrust authorities should also count in their assessment the implication that, for example, a merger may have on the environment. Okay, so the difficulty there is that you go from a very precise concept, a measurable concept, as I said before, which is consumer surplus, to other concepts that you may want to use in order to assess your decisions as an authority that are much more blurred, or at least currently, we are not so, we don't have the tools yet to precisely measure these other concepts. So it's a very important and interesting debate, I think. We are not there yet with a clear answer if and how authorities should start thinking in these terms. But there is a very interesting debate on this area.
So you're saying because consumer surplus is mainly based on estimate the demand, and you have some math formula and you get
exactly
the consumer surplus, which is not the case for these other elements. I'll go to the second part of the antitrust role of competition authority that you mentioned, which is collusion. And there are a lot of interesting cases out there in the past. But you're working on some new interesting cases which talk about collusion among algorithms. So maybe you can tell us the setup, what question you are trying to answer in thinking of collusion among algorithms.
Yeah, so it's a research that started with a group of co-authors, I would say now 5-6 years ago. These co-authors are Emilio Calvano, Vincenzo Di Nicolò, the same person I was mentioning before, and a colleague from the University of Bologna, Sergio Pastorello. And the idea was the following. So we are nowadays seeing more and more application of artificial intelligence in markets. One of those applications that is broadly discussed is the use of AI, artificial intelligence, for pricing decisions. Okay, it's kind of not obvious because pricing decision for a firm is a very important decision. But the idea is that firms may start delegating to algorithms the decision on price that they're going to use to sell their products. Okay, in a sense, it's not a novelty because if you look at the industry like hotel or airline industries, they were using, or energy, they were using algorithms since the 80s of the past centuries. So the novelty was realizing that we are talking about nowadays of a different class of algorithms. Algorithms that are designed to learn how to behave, in this case in the market, how to price autonomously. So autonomously means that the computer scientist that codes these algorithms tells the algorithms what is the objective. Typically, a firm would like to maximize its own profit. Completely legitimate, of course. Otherwise, as a manager, you would be kicked out quickly. And so you instruct the algorithms what is the objective. You tell the algorithm to explore the environment, that is, to collect information from the environment and learn through this information that is coming from the environment. The environment would be, in our case, just a market, the behavior of other firms.
So if I, just to set context, so let's say you're booking.com, like which is a platform, and then you're a big hotel chain, and there are these competing hotel chains. They write their own algorithm. Is that the setting?
Exactly. That's the setting. I'm very cautious in mentioning that we haven't proved at all actual collusion in markets. So what we have studied is provided is a proof of concept that this type of collusion that I'm going to specify in a moment is possible. Okay, but the environment you're saying is correct. So you are a seller in a platform, then you may use algorithms to set the price that consumers will see for your product in that platform. Okay, so
and I guess it's very common, even on Airbnb. I guess people don't feed in the prices themselves.
Exactly. Almost all platforms are allowing sellers, to integrate their software in order to have this automation of the pricing decisions. Almost all platforms. For good reason, because algorithms can be much better than humans in responding effectively in a timely manner to changing demand. And that is good for market efficiency. So an important, preliminary statement that I want to say is that algorithms are not evil at all. They are a fantastic tool that can generate large market efficiency for the benefit of everybody, including consumers. We discovered that some algorithms may have this ability, once you tell them to learn, also to learn a very effective way to generate profit for their firms, which is colluding. Now, what is collusion? Collusion is a strategy that firms with market power can rely on, which allows them to sell at higher price, higher with respect to what would be competitive prices. Okay. Now, collusion is a difficult strategy to enforce, because suppose the two of us, we are seller on a platform, and I tell you, look, we want to maximize profit. The best way to do is to sell at high price, okay? And you say, okay, that's true. But then you walk away and you realize, well, is selling at high price. What I should do is selling at not so high price, a little bit lower, and get most of consumers, because the consumers would follow you selling at lower price. Okay, so the agreement that we had before shaking our hands,
there's
vanishes.
No way for enforcing this commitment.
It's difficult to enforce. The problem is that that's good for consumers. The problem is that you can enforce collusion even if you cannot rely on written contracts. Why you cannot rely on written contracts? Because as we were saying before, antitrust authority prohibit collusion, so that would be a null contract that we would be fined immediately. Now, there is a possibility to collude, and actually firms have been caught in many different markets to collude, right? And the ability to sustain collusion without this type of written contract is through essentially threats, okay? So we realize that the two of us, we are interacting in the market not only today, but also for the next 10 or 15 months, right? So when you walk away and if you decide to, let's say, cheat on our agreement and reduce the price, I could have told you before that if you try to do this, tomorrow we're going to punish you with very low prices for 5 months. So you may have an immediate gain by cheating on our collusive agreement, but you know then that will be a significant punishment and very low profitability for you as well in the future. So it's this type of assessment of gaining today by cheating and losing tomorrow because of your cheating that somehow limits the incentive to break a collusive agreement. So in fact, collusive agreements of this type are effective in the markets also.
So the antitrust authority tracks these kind of behaviors?
Right, they do. But you see the difficulty. They cannot simply rely on contract that we've written, because this is something that we never do.
But they also track, like if you are calling or something, right?
Exactly. So they look for what they call hard evidence. So typically the hard evidence authorities rely on is they record phone calls, they even record video record meetings when they are suspicious about some collusive agreement, they follow managers. It's like a movie plot. Actually, there are movies on this.
But this is just in Europe or
all over the world? Because as I said, it's one of the pillars of activities of antitrust authorities, fighting collusion. And this is the way you fight collusion between humans.
Now, but you have to get like some court permission, or you can just
well, it depends.
Listen to phone calls just like that.
It depends. It depends on the countries. On this side, countries can be very different. Some cases you need to rely on court's order. In other cases, antitrust authorities, they have the power, or investigative power, to look for these Arth evidence.
In Europe, they must be doing that.
They do. Yes. Okay. And so the difficult part of the job for them is precisely looking for this Arth evidence. One, we call this Arth evidence because it's recorded. Once you have it, then you can go to a court and say, look, these guys have colluded. We observed they materially increased the prices, and we also have the proof that they had an intention to do so. Okay, so that's important. So the Arth evidence is to prove the intention that we wanted to make this agreement, shaking hands and increasing prices. Now, going back to the algorithms, what's the problem with that? The problem with that is that, imagine the two of us, we delegate pricing decision for our products to, I delegate to my algorithm, you delegate to your algorithm, and then we let the algorithm do what they are designed to do, right? To optimize my profit, my algorithm, your profit, your algorithm. If these two algorithms, by interacting over time, they realize that the best way to maximize profit is to increase the price, and they are able to do so, then who is responsible for that? So us as managers or owner of our algorithm, we didn't instruct them to collude, right? They autonomously learn to do so. So what we have done in this research, is building a market environment, a reasonable market environment, populating this environment with sellers which were delegating the pricing decision to these self.
So this is all simulation.
It's all simulation. That's important that you mention, because as I said before, it's a proof of concept, right? So as economists, we claim that we were able to represent markets in a realistic way, very similar to real market. We did our best to use algorithms that computer scientists would suggest to use for this type of pricing decision. So we populate this market with these algorithms, and through simulations, we watched essentially from the outside what was happening in the market. And I can tell you somehow how we came about with what we discovered. So at some point, we realized that after some time, these algorithms were selling at very high prices. Okay, that was unexpected. Well, unexpected. So it's a significant outcome. Now, you can.
So if I understand this correctly, you already had the simulated environment.
Yes.
But you were not studying collusion per se.
Exactly.
You were using it for something else, and then you saw very high prices.
No, we already had in mind that was a possibility. So we built this machinery to understand whether autonomously learning how to collude was a possibility for this type of algorithms. And as I said, we noticed high prices. Now, high prices, you can interpret in different ways. It could be that algorithms weren't able to learn how a market functions, and that if you want to acquire market share, you may want to reduce your price, okay, and then attract more consumers, or something else. One option for something else is that they learn to collude. Now, I might say that being an economist doesn't expose you to many, kind of mind-blowing discoveries. But this is one case where it happened to us when we observed what I'm going to describe you.
So just to get the context right, so how many algorithms did you have on this platform?
So we tried several different scenarios. Let's talk about the simplest scenario, which is two firms and then two algorithms. Okay?
Yeah, so I was getting like, maybe it's more difficult to collude among many.
It is. I'll come
Okay,
back on
okay,
that. So, but
okay.
we tried also with markets populated with
Okay.
more algorithms. But let's start simple with just two, so we can
Yeah.
can go on with the two of us using these two algorithms. The difficulty is, and I think it's interesting because it's at the intersection between economics and computer science. So when you start using artificial intelligence tools like the reinforcement learning algorithms that we were using in these experiments, you realize that it's not so simple to look into the algorithm once the algorithm has learned in order to understand what
It's a
it
black
has
box.
learned. You can try, we try in many different ways, but in the end, it's almost a black box. Okay, so it's a problem known in terms explainability of artificial intelligence.
So basically, your goal was to find out, are they really colluding or are they
Exactly.
just stupid?
Exactly. That was exactly the point. But if you try to open up these complex machineries, these artificial intelligence objects, it's very complicated. And it's built on a language that as humans, we really have a hard time to understand. So then we had an idea, which was a very simple idea that you may observe in Economics 101, which is the following. So we took one of these algorithms and we forced this algorithm to do what I was mentioning before. That is, just for one period, cheating and setting a lower price. So we forced the algorithm to set a lower price just for one period, right? And hence, we left the algorithm free to do whatever they have learned to do in the past. So we discovered that if you impose this cheating on by one of these algorithms, the other one, immediately after observing the price reduction, the cheating, would have started immediately to punish with low prices for a significant period of time, which would make in the end the cheating non-profitable. So we call it incentive compatible collusion, which is exactly the sophisticated mechanism that I was talking about based on threats and punishment before that humans are using. So that was.
So it's interesting on multiple dimensions. Like the first is, of course, that they're colluding. And the second is that they found kind of punishment which we have already seen before.
Exactly. And I would also add that us as managers, to strike this implicit illegal agreement, we need to talk. We need to exchange views of what you can do if I try to reduce my price unexpectedly, or vice versa, what I could do. So we need to talk. That's the hard evidence competition authorities are looking for. So they're looking for this explicit intention, explicitated through talking.
So the interesting part of your paper is then you can have this one line of code saying punish or like cheat once.
So the interesting part is that at the origin, when the algorithm were initially deployed by the computer scientists to behave and work in the market, there was no such a line. As I said before, the only instruction gave by the computer scientists was, you should maximize this profit and you should learn through the environment. And then the algorithm learns. After some time, that line that we were mentioning was written in the code, but it was autonomously learned by the algorithm with no communication, or at least not the type of communication that us humans would use in order to strike this type of agreement. So then once you realize that this is a possibility, the difficulty is there for competition authorities because they will never be able to find hard evidence of intention unless you start discussing whether algorithms are, like well-being, motivated by intentions.
No, but it's still interesting because they might be pricing in whatever way, although I guess it might be difficult because you are hard forcing them in some sense to cheat at some point and then see the reaction in the market. I guess it would be tough like any other public policy.
Right.
You can't experiment on the market, or you can't experiment
It's
on a large scale. So it's a difficulty like that.
Exactly. So it's difficult to find. So in a sense, I would say that it's difficult because the tools that currently antitrust authorities are using for humans, they wouldn't apply for algorithms. You cannot find hard evidence of the type I was mentioning before. The interesting part, though, is what you just mentioned, that is this experiment that we did, the way we somehow discovered and we were able to open the black box of the algorithm, which was this little trick, forcing for just one period and seeing what was the reaction of the other players. It's something that you can do. So as an authority, right? If you have the authoritative power to intervene in a market and say, look, wait a second, give me your algorithm and I test it. If I see that the algorithm has learned to do this type of thing autonomously, and I can do this test bed analysis in a simulated environment precisely as ours, as the one we developed, then you have the hard evidence.
No, but this is interesting. Yeah, I mean, there is a hard evidence, but the first scenario that you ran, you didn't tell the algorithm to collude.
Yeah.
They just did it. And a lot of managers might be just lazy and just say, okay, just do your thing. So they never intended to do it,
Right.
But the algorithm still did it.
Yeah. So in fact, there are two important dimensions, or I would say two difficulties. One is detecting collusion. And in a sense, algorithms, through the type of exercise I was mentioning before, forcing for one period and checking, are simpler than humans. Because if you go to a manager that you suspect is organizing a cartel with other firms, and you ask, are you colluding? Of course, he would tell you no, of course. No? An algorithm would tell or would act as it has learned to do. So on that side is, in a sense, it's simpler than with humans. On the other hand, it's precisely what you said. Firms that are using this algorithm, they never intended to organize collusion. Yet these machines autonomously learn to do so. Now, where the responsibility of this outcome relies, I doubt we can say it's the fault of the algorithm because it's not an individual object, or till now we haven't associated with algorithms this type of responsibility. Is not the responsibility, given the current status of antitrust authorities and the tools that they're using, is not the responsibility of the manager who started to use the algorithm either, because the manager had no intention. It can prove having no intention for collusion, and yet collusion generated. So this type of situation, I think, speaks of a very similar and common situation in other environments whenever we start using artificial intelligence in markets. Who is responsible for the outcomes of artificial intelligence, which could be fantastic, positive outcomes for society at large, but can also be problematic? I think that's a general debate, and probably economists may have something to say. I hope so.
I mean, I can only see that antitrust authorities would probably hire computer science engineers more now. There should be some
They already started to do so.
But following on it, so you ran a simulation experiment and you found that they learned this collusion on their own. Are there people currently working, trying to find out whether you have this behavior in the real world as well?
Yeah.
And the reason I'm asking is also more from a financial market side, because we know a lot of trading is algorithm based, and it's just algorithms trading with each other all the time.
Sure. So one thing, as I said, I was very cautious in mentioning this, is proof of evidence. Going from there, from simulated environments, we said, into the real world. Okay, we have to be very cautious. And the things in the real world are more difficult. It's more difficult to pin down exactly what's happening. There are a couple of papers that started to analyze in the real market. For example, there is one paper on gasoline market in Germany to study whether the introduction and the use of algorithms of a similar class of those we have used in our simulation may be associated with price increases. And there is already some evidence, some quite convincing evidence that the introduction of these algorithms was in fact associated after some time to price increases, right? Slowly, because as I said, in the real market, finding good data in the real market is much more difficult than in simulated environment. I think we're going to see some evidence piling up of this actual possibility. Again, I want to be clear, this is not to say that whenever we will have pricing algorithms in markets, we will certainly have collusion. Not at all. As I said before, and financial markets are a clear example of that. Algorithms are a very effective tool to improve the efficiency of markets because they allow us to respond very quickly to changes in demand and supply. So they are a very, very important tool. They may come with these drawbacks. Let me also mention that financial markets are not immune to collusion. So there are cases of collusion between humans, real human beings in financial markets as well. Whether this will be in the future the case also because of self-learning algorithms, we don't know yet, at least to my knowledge. I don't know yet of actual cases in financial market of this type. But it could be because, so it could be for me, from my point of view, means we have to remain vigilant because it's true that in financial markets, algorithms have been used for decades. And very sophisticated algorithms are in fact developed for this type of market.
So I'll go back to your paper once again, just to close the loop.
Mm-hmm.
We started with this example of 2 players. And generally, we know that collusion becomes more difficult if you have multiple players. So in this algorithmic collusion, was it similar case or they all learned at the same time?
It is. So we know from theory, theoretical industrial organization, as we were mentioning before, that more, and we also we know from practice, for empirical analysis, that more firms in a market, in a given market, make the sustainability of the type of collusive agreement we were discussing before more difficult. Okay, so the more firms are in a market, the less firms are able to make these agreements, collusive agreement, sustainable in the long run. Or in other terms, there is higher temptation for some of these many players to cheat on the agreement and to break down the entire cartel. Okay, so the interesting thing is that, of course, we did this type of analysis also in our environment, and we do observe the same. Algorithms have harder life in supporting collusive agreement. The more algorithms or the more sellers there are in the market. So from that point of view, they are similar to humans, and for a good reason. The type of collusive strategy that they have learned, at least in our experiment, to use are exactly the collusive strategy that humans use in market. So the general properties of the ability to sustain collusion are almost the same that you would observe for humans. In fact, we did a lot of extensions, robustness check, and we systematically observed that the ability to support collusion by these algorithms very much reflects what we already knew could happen when we were talking about collusion between humans.
So in some sense, it's good. You just have more algorithms.
Well, as I said,
more views of dominance in the algorithmic market.
Algorithms are very useful. We have to watch out what they can do as an outcome in markets.
I'll go to another one of your recent papers where, again, algorithmic recommendation system, and you mentioned that increasing the amount of data available to the algorithms may lead to a reduction in consumer surplus. So maybe you can give us the setting, but generally we think that if you give more of your data to Netflix, to Amazon, the better they are able to recommend things to you.
Mm-hmm.
But you're saying if you give them too much information, then at some point the surplus starts reducing.
Mm-hmm.
So is it a similar setup or?
Okay, so that's another research on recommendation system or recommendation algorithms, which are another a very remarkable type of artificial intelligence application in markets. Before going to the implication on consumer surplus and information, let me tell you what we're talking about. So essentially, we nowadays live in oceans of products, right? Think about when you enter into Amazon, in Amazon Marketplace, nowadays you have, if I remember well, around 350 million of possible products that you may want to buy, okay? If you log into Spotify, the catalog of Spotify is 90 million of possible songs, and so on and so forth. 28 billion of videos on YouTube, okay, including yours. So how do we choose among how do we navigate this ocean? So recommender systems are algorithms that are exactly designed to give users, consumers in these platforms, personalized recommendations. It's the word personalized important because it means that the recommendation that you would receive on Spotify on what type of songs to listen are different from mine because we have different preferences. These platforms collect information on our preferences, on preference of similar users, on similar songs, similar products, and then they're able to give us personalized recommendations. Now, what we have done with this study, essentially, we used a similar approach that was mentioned before. We simulated markets. Again, the approach is similar. Now we have a market. We build a simulated market where consumers are exposed to this gigantic number of options they may choose from. Without a recommendation system, they are somehow forced to follow some type of search, word of mouth with friends, which is not, it comes with biases. It's not necessarily that your friends are recommending what you would like to watch or listen, etc. So that's a world without recommender system. No? And then we introduced in this environment recommender systems, again, using algorithms that are close to the algorithms that these large platforms are using for to offer recommendation. And then we study what happens if we give a personalized recommendation to each one of these consumers. What happens in terms of market outcomes? Market share of items, products, musics, videos, and etc. That was the first step. Then the second step was what would be that was the reaction of consumers, of users. Now the second step was what would be the reaction of sellers that sell in platforms once they realize consumers are using platform recommendations in their decision process, right? And the typical strategy that we studied from the point of view of the sellers was the pricing strategy, whether sellers were reacting to increase or reducing their prices once they internalize the fact that their users, their consumers, are receiving these personalized recommendations, right? So that's the agenda that we set up. And I can
So this is basically like Amazon. There are some preferences, and then as a seller, you can choose your price.
Exactly. Yes. Okay. So Amazon is a platform, is a gigantic marketplace where millions of users, consumers enter the platform looking for some type of products or even not having a great idea what they would like to buy. On the other side, there are many sellers that are populating the platform, but the problem is that the consumer doesn't know all the products that are available, okay? So it can start searching for specific items, specific product, or it can rely on recommendations that Amazon provides to these consumers. As I said, recommendations are very specific, very personalized. So that's the type of environment. So we replicated this type of environment. So the first set of results that we obtain is that if you look at consumers' decisions, by means of the recommendation, they tend to be very much concentrated on a relatively small set of items. Okay? So in other terms, the recommender system tend to concentrate market share in the hands of few sellers. Okay, that's the first outcome. You may say, well, that's not great. Still, if you look at the consumer surplus, what we discussed before, with the introduction of the recommender system, the consumer surplus significantly increases. So notwithstanding what I was mentioning before, that is this increase in market concentration, the net effect for consumers is positive.
So this is based on what they are searching, or in general being on the platform and being recommended something?
Both of them.
In both
right.
cases,
Because in our analysis, we'll always give the consumers the ability to recommend, to search,
okay.
right? That's very important, because another chapter on recommender system is the possibility to manipulate recommendation, okay? And I'll come back on that. So the first chapter was impact on market share, concentration. Second chapter was what is the implication on consumer surplus. Consumer surplus increases, so it benefits a lot consumers. The third chapter was what is the reaction of sellers now that they know that their consumers, their buyers are using this personalized recommendation. And here the reaction of sellers is less benign for consumers, because sellers react increasing prices. Okay? So in the end, consumers will find themselves in an environment where they're more able.
So this is a dynamic setting, like same set of sellers. So they gain the market share first, and then after some 100 iterations, then they increase the price.
They realize that they have the possibility to increase price.
Okay.
Exactly. Okay. So as a consumer, you end up in a world where you consume fewer products. You are paying higher prices. The net benefit, your consumer surplus, once you account for this price increase, is still positive. But now the price increase eats up a little bit, or a significant part of the ability of the recommender system to recommend you a product that is a better match with your preferences. So there are these two countervailing forces. Recommender systems are very effective in giving you good matches product, but the market reaction is a price increase as a consequence of the better match consumer
So the information part that you're talking about here is the
information part is exactly the combination of all these two chain of reasonings.
Okay.
If I give
more information with the seller,
more information to the recommender system. If I give more information to the recommender system is able to give you better tailored recommendation, but at the same time, sellers are better to charge you even higher prices. So that is where we find a trade-off. Actually, we find a U-shaped relationship between net surplus of consumers, that is consumer surplus, and the information that you give to the recommendation system. That's at some point we claim in this analysis that even though it may be too early because there is relatively little research on the recommendation system, we may think about limiting. One possible policy could be limiting the amount of information that the recommender system use. But again, I want to be very cautious on this because it's very early, at least for us, into this type of research. And certainly we need more research.
So this is all simulated, and I know Amazon wouldn't give us their proprietary algorithm.
No.
But don't they punish some of these guys once they start charging more?
Again, we go back to what to do in terms of antitrust policy. You cannot simply punish a firm that charges higher prices. So
but there are different players here. It's and maybe you're setting, I'm not sure, the one algorithm was for the recommendation system, and I guess there were another algorithm for these sellers.
Well, we haven't done that. That's too complicated. So what we have done is we have this platform, buyers and sellers. The platform provides a recommendation system. Okay. And then the recommendation system provides information to the consumers. And then the consumer decides which product to buy. The sellers are just using.
So it's not automated.
It's not entirely automated. Although if you combine the two research we were discussing, pricing algorithms with the recommendation, we have an environment where many of the activities are automated. Maybe that's the future.
But even otherwise, I mean, I'm thinking from like this big marketplace perspective, it's probably not even good for them. So it's not just about the
Absolutely.
antitrust authority,
Absolutely.
because in the long run, they care about this platform to give good recommendations,
Yeah.
but also cheaper prices probably.
Exactly. Yeah. So we know platforms works exactly in this way. What you want to have on board as a platform is both sides. You cannot please only sellers. You have to please sellers and buyers at the same time. So it's a difficult balance.
But if they open their own cloud kitchens, if they start manufacturing stuff which they think has higher margins, then it's a problem. When the recommender starts manufacturing.
I can tell you a few words if you want on this, because one part of the research that we are doing is in that direction. So one criticism on a recommender system that is out there and common is, well, you as a platform may have an incentive to manipulate recommendations. One reason for that is that if as a platform, you also become a seller, okay? Now, if you as a platform, you become a seller, you may have an incentive to tell consumers, look, the best product for you is my product, okay?
Isn't there an antitrust case on it already?
There are cases on that. Okay, so, but let's stay more on the abstract side. And what I can tell you out of my own research. Of course, you can manipulate recommendations. Okay, that's very simple. For a platform, it would be extremely simple. But as you said, it's not obvious that you may have the incentives to push that manipulation very far. One is already there when we said that if you manipulate recommendation too much, consumers may walk away, because you are recommending them products that are not anymore a good fit. They realize that maybe they might buy once, following your manipulated recommendation, but tomorrow they may leave the platform. So there are limits. Another limit that we have identified with this research is that if you try to manipulate recommendation, then it turns out that you reduce the average prices, the prices in the market. The market reaction of all the sellers would be to reduce prices. And this would hurt you and your product that you want to try to favor. Okay? So we see that there are several limits to manipulation. I'm not saying
there are market forces.
Exactly. I'm not saying that it's not happening. We will see how these cases will go. What I'm saying is that there are market forces that certainly can limit this manipulation. And so that's an important element to keep into account.
On the more logistical side of it, I can see that you have like series of papers on this issue. How long does it take to create this kind of simulated economy? That's a big part of the project, I guess.
Right. It's a big part of the project because, as I said, you have to be convincing on two dimensions, essentially. One is that the economic environment that you build is a realistic one. And on this, I may say that, as economists, we know our job awfully well. We are trained for that, and I think we can do this work reasonably well, but you have to be precise. On the other hand, the second element you want to be convincing on is the type of algorithms that you are employing in order to make this type of research. And on that, you have to rely on what computer scientists are doing. So we have had a lot of interaction with these researchers on computer scientists. We interacted with them to understand what type of algorithm they would use or they are actually using for specific purposes. Okay, so combining these two things requires some careful analysis, requires some time. But I think it's not very complicated in the end. Conceptually, it's a relatively simple approach. And in fact, we start seeing authorities using similar approaches. So also thinking about what's happening in financial markets with the fintech world, these new companies come up with very new ideas, financial products that we have never seen, business models that we have never seen. I think authorities that somehow take care of this market they may have a possibility to build similar environments to test these products, these new business models in parallel when they are deployed in the market or even before they are deployed in the market. So it's called sandboxing, and is already in use in some environments, financial markets, for example, for fintech. And the fact that competition authorities are start hiring computer scientists is also hinging in that direction.
It's a bit of self-critique, but how close are these simulated environments to like the real world cases that you're studying?
I would say they're perfect, of course. No, they are close. So from the economic point of view, we are essentially using the same models that economic analysis is using to describe markets, and the same tools that are used actually in antitrust cases. So essentially, the demand estimation is based that are used in antitrust cases is based on a methodology, on a behavior of consumers that is the type of methodology that we also use in our analysis. That is called a discrete choice model. So on that, they're very close. In terms of the algorithms, we did our best to be as close as possible. It's not simple though. We have to be clear on that and fully transparent. For example, in terms of recommendation systems, these big platforms, they will never tell you exactly what the details of the algorithms. But at least we can look into the catalog, into the shelves of these tools that are designed by computer scientists and identify classes of algorithms that reasonably are the algorithms in use by these platforms.
So last question, and I probably would ask you to again put your industrial organization head. So we are hearing a lot about these large language models for more than a year now. And of course, there's debate about they're going to replace labor and a lot of other discussions around this issue. But from an IO perspective, what is an interesting question to look at in this domain?
Well, that's a very difficult question because there are so many different and interesting questions to address and to think about these LLM models, large language models, that it's very difficult. So maybe a less obvious answer to that question would be, and this is really what I'm interested in, is rather than the implication of the applications of these very important AI, artificial intelligence models, I'm interested to understand what is the market structures of companies that are producing and offering these algorithms, right? So if you think about nowadays, which companies are producing these LLM models, well, there are few very large companies. Now, the question to me is, what will be this market of these very important players 10, 15, 20 years from now, when these technologies will be developed in a way that we cannot even conceive and understand now? So if I want to make a parallel, thinking about what happened with platform economics and platforms in the last 15 years, there was a lot of market concentration. We know that we have seen, we nowadays see very few and extremely powerful platforms. To some extent, this process went on its own. There was not so much intervention in this market by antitrust authorities. So this is where we are now with platforms nowadays. Now, will it happen something similar also for these large language models, or in general, the developments of artificial intelligence also in the future will be in the very few hands? But notice that being few hands is not necessarily bad, no? Because in some cases, concentrating can be good. So in the history of industries, we have seen concentration for very good reasons. When we were talking about telecoms 20 years, 30 years ago, there was a good reason to have concentration in very few firms. It was the notion of natural monopoly. So in principle, concentration is not bad.
It's not always bad.
It's not always bad.
So let me ask like a more practical question, which is, of course, whether these companies get market power is something we'll have to wait and see. But there are already some antitrust cases against these companies in terms of using publicly available data.
Mhm.
And since you probably track the competition authority and antitrust cases, do you think there is a good case against these companies that they use this publicly available information and now they are going to get most of the benefit out of it?
Look, it's so novel and new that it's really difficult to understand how these cases will end up. I don't have a good answer for that. So this information was, this data was there, was available, and that was a completely novel use that was not conceived initially. So I think it's going to be really difficult to, at this stage, say, well, that was red light rather than green light. So it has to do with one important element that I think will be certainly very important for antitrust and competition policy in the future, which is catching up with our way to understand how to analyze how to analyze markets with very dynamic markets. You know, in a sense, CPUs, the chips that we were talking before, they were subject to some technology advancement, but not at the speed and the pace that we are talking about nowadays with platforms, with the artificial intelligence deployment of it in markets. So it's going to be very interesting times for competition authorities in the future, I'm pretty sure.
So if that was Intel saga, maybe this one would be ChatGPT saga, and maybe it would take 10, 15 years to decide on this case.
I don't know. I hope not, because these long saga are not good for companies, are not good for consumers. So I hope that we will learn in a much quicker way to understand the rest cases.
It was great talking to you, Giacomo. Thanks for your time.
My pleasure.